Hello, dear viewer. Well, allow me to begin with a little allegory today. You see, I was reading an article in some newspaper or a website, as the case may be, from out of India. You see, a man was riding a motorcycle with his wife and child in back when out of the blue, a leopard pounced from behind the bushes and attacked them. And this guy, rather than taking it from the leopard, leapt on the leopard himself, hit it a bunch of times, and sure, he himself got bruised and battered and he was bleeding, but he managed to hit the leopard so hard and strangle it eventually that the leopard died. Now, eventually the story, which I'm going to link below, it turns out that the mob attacked the leopard. They set traps for the leopard from a vet. I'm not exactly sure why. So there's an autopsy on the leopard, and they don't really know why it died. There's more positions on this story than Kim Kardashian. But the point is, much like the man and the leopard, when faced with some sort of LeetCode problem, you better attack it to the best of your ability. You don't know where it's going to come from, but you have to use every resource in order to resolve the story. Which brings us to LeetCode number 17, letter combinations of a phone number, which asks, given a string containing digits 2 to 9 inclusive, return all possible letter combinations that the number could represent. Return that answer in any order, or the answer. A mapping of digits to letters, just like on the telephone buttons, is given below. Note that 1 does not map to any letters. So, okay, you have the 2, and as you can see, there's the ABC related to it, DEF over here. And we see that with 23, you could spell all of these words over here. With nothing, you spell nothing. And with 2, it just dishes out every single letter combination of 2. So that's how this works. You just do all the combinations according to the number of letters that you have, which we're going to call index. So that's the position vis-a-vis the letters that you're at. So how do we start this? Well, it appears it's a backtracking problem, which means we're going to try out the combination with one number, then we're going to come up with all the combinations subsequent to that, and then we're going to throw out the number. It's kind of like when you go camping, and when you're done, you just remove your stuff and leave out any trace that you're ever there, for the next people to come in. That's kind of what's happening. And after all, aren't you just like a number yourself? So let's start this. First of all, a little sanity check as per usual. If our digits are empty, then we return nothing. And that's going to solve this case over here. That was simple. And next, we need something to represent this. We need something to represent these numbers over here and their associated characters. And for that, we better use a map, and more specifically an unordered map, because we don't really care what order these numbers come in actually and how they're stored. And so an unordered map, and if you don't know these things, I suggest you look into them, is a hash table. So it's going to be, so each character will have a string associated to it. That's our unordered map, which we're going to call my map over here. And then we're going to create this, we're going to create a vector. Let's see now, we're going to create a vector of strings, just like what they ask, and we're going to call it my return. And after all is said and done, we're going to return my return. But meanwhile, we have to populate this my return, and to do so, we're going to do it with some sort of magical function here, which is going to populate it, and we're going to call that magical function get letter combinations. When you don't know what to do, you just should at least come up with the return, and you're saying, okay, my mission is to populate that return. We're going to pass this by reference, and then for every pass, we might want to throw in the current combination as it is now, which at this point is empty. Then we want to throw in the index, which is the digit that we're looking at. And then we want to throw in the my map, which I'm going to show you in 2 seconds. We're going to pass by reference. And then we want to pass in the digits themselves. That's what we're throwing in. So let's see how this looks. So void get letter combinations, and let's let's immediately throw in the my return over here, which we said we were going to pass by reference. So the reason is, as we go along this recursive function, we're going to populate my return with the current string, which in itself is passed by value. So suddenly, so we're going in, we're putting in letters, and we're iterating down the kind of the index. We're incrementing the index each time in string, and getting the combinations based on that. So hold on, we're going to see that in 2 seconds. So let's see now. Int index, that's our current index. And what else did we throw in? We're throwing in the map. And again, you better pass this by reference so that it doesn't copy it needlessly. And as well as the string itself, which is digits, that also you want to pass by reference. And since it doesn't need to be changed, you could put that little constant there. I recommend kind of, even though we're not going to touch this map over here, I would stay away from the const keyword for that. Sometimes I've noticed some anomalies, although I won't get into that right now. Okay, so let's see now. The first thing is, this is going to be a recursive call. So the first thing is that we have to check that if the current string dot size equals, let's see now, digits dot size, that means we came up with a good current string. So that means we could populate my return with it. And return immediately. Well, we got interrupted. Where were we? Okay, we were saying that when it hits this current string size equals digits size, that means that we reached an appropriate size of the current string, which we've been feeding. We've been incrementing this current string. So how do we actually increment it? Well, we do it by a selection of the current number. We look at the current number that we're looking at in digits, which corresponds to digits at the particular index, and we take all the letters that correspond to it at that particular point to see how we can feed that current string. So let's look at that right now. So let's say we had, I'm not sure why the indentation is a little off here. So let's say we had a string called, let's see now, letters. Let's call them letters. And actually, let's stick to our nomenclature. My letters equals, let's see now, my map. And what string are we looking at? We're looking at digits index. So the letter that it gives here is the letter at digits index is the one that's going to correspond to our map. Oh, and speaking of which, we forgot to create our map in the first place. So what is this map? Yes, let's populate it here. So my map and equals, so one particular character, which is a number, is going to equal some string representation. So 2, 3, 4, 5, 6, 7, 8, 9. Let's see, 2, 3, 4, 5, 6, 7, 8, 9. That's how we do it there. A, B, C, D, E, F, G, H, I. Got lost in here. As you heard, I had a phone call. M, N, O, T, U, V, and 9 corresponds to W, X, Y, Z. And yes, I'm Canadian, we pronounce it Z, not like those subhumans to the south of us. Now that we have the letters that we want to scroll to, so you see that once we find the digit within digits that we want to search, we get the string associated with it, and that's when we could iterate around that string. So we could do this with that, well, I forget what you call this type of for loop here, using the auto keyword, but notice that we pass it by reference over here, so we're not doing needless copies. As we said, where we're pushing back the current element that we're looking for, and then we do some sort of recursive process, and this is available within our strings as well. We could pop it back, and meanwhile, we're going to call our get letter combinations, and we're going to throw in my return. We're going to throw in current string, index +1, we increment it. We're going to throw in my map, and digits. So that's the only thing we do. All we're doing is taking a letter, going through all the combinations after that particular letter, and then removing the letter. So you kind of see that going on here in this third example. So at a minimum, you're always iterating through all the combinations of a particular letter. And then after that, well, let's see if this miraculously runs on the first try. And it does. And we submit. And it works. And it works well. Thanks a lot, everyone.